Hello, I'm here today with the co-founder and CEO of Mosaic ML, Naveen Rao. First of all, thank you so much for joining us.
Absolutely.
So first question just for the audience. Who are you? What have you done? Clearly, one of the leaders and pioneers in artificial intelligence and machine learning. So give us some of your background and your history, because you didn't start out there.
Well, I don't think anyone really started out there. This is a new field, and I think it requires people who are maybe a little crazy and try different things, combining other fields. And so my background, I've always been interested in the idea of synthetic intelligence. One fact that I thought really pushed me into this field and just made it amazing is that our brains run on 20 watts of energy. Everything we are is 20 watts of energy. That's like your laptop, right? So
I'm thinking that's it. That's all we've got.
Right? It's not much. And so I learned that in college, and it's one of these things. I actually did some research on neuromorphic circuits and stuff like that. After college in the late 90s, I happened to be witness to the whole .com bubble and bust and all that good stuff. But I was in Silicon Valley, dropped out of grad school and went to a startup, the usual kind of stuff. And after 10 years in industry, I designed chips. I built software stacks. I built applications. This is when the tech industry is really growing and becoming what it is today. I was a part of a lot of that stuff, and I said, I actually want to go back and understand this question of how can we make computers intelligent. I quit my job and went back to grad school and to study neuroscience, computational neuroscience, and it was a lot of fun actually. I worked with animals and listened to neurons and used machine learning to understand patterns in the data. But through that, I actually got a really good understanding of how the brain processes information. Mm-hmm. And some of the fundamental concepts in the brain that are vastly different than the way we do that in a microprocessor. And so, after graduating, I spent a little bit of time in finance as a quant, and then actually went back to the research world and corporate research at Qualcomm, and was researching neuromorphic architectures. These are computer architectures that are inspired by the brain. So it's right down my alley.
Good thing you defined that. I was about to ask you about, what are you talking about? So computer architectures that mimic how a brain works.
Correct, yeah. And at that point I said, well, neural networks are not just this toy or this method. They're actually an entire way to do computation. In fact, they even define the purpose of a computer. And so then kind of reasoned, hey, maybe it makes sense to build the correct substrate. If a computer is going to be this, its architecture should reflect that use case. And that's actually what went into the idea of my previous company called Nirvana Systems. Mm-hmm. We started in the beginning of 2014, and we were the first AI chip company in this whole new slew of things. And I think it's actually quite incredible that we left this indelible mark on computer architecture. Every computer now contemplates AI and the computations that we sort of laid out in that way. And so I take that as a win. We were acquired by Intel in 2016.
Which is also a win?
It was also a win, yeah. But in terms of sort of that academic mindset, you want to influence thought and influence technology, and I think that's what was really amazing for me to see. Right.
So you were Intel for a few years.
Like 3 years, yeah.
Now you're doing another startup. So maybe talk a little bit about MosaicML and what you're doing now in the field of AI.
Yeah, so it's continuing the journey, honestly. We recognized even back in 2014 that neural networks are going to get bigger. Mm-hmm. And they're going to get bigger because they bring on new capabilities. We didn't know exactly what form that would take, but we knew that trend was going to happen. And we actually built that architecture to support that. So fast forward to 2017, 2018, that's when you started seeing generative models like GPT. For people that don't know that, GPT was a neural network model that was released by OpenAI, and it's conversational. You can ask it questions, and it gives you responses that look very human, actually. And it can almost reason through some basic facts, connect things together that weren't given to it. So pretty incredible. But it came at a cost, a literal cost, is that training one of these became very expensive, mm-hmm. like $5 to $12 million.
Yeah, that's a lot of money in anybody's book, right?
Exactly, and I mean, if you're an enterprise company, spending $5 million on an experiment's not such a great idea, maybe, or it's very hard to get the budget to do so. And we recognized this, and actually, when I quit Intel, we wanted to continue the mission of we want to make ML, machine learning, accessible to everyone. Part of it was this cost problem. How can we make costs lower? And so hardware was kind of chugging along. People are building new architectures, new innovations. Software optimizations are kind of moving, but this only results in 40%, 50% per year decrease. We need more like 400%. And so we started looking at the math of how neural networks learn from data. And that's where Mosaic was born, was can we actually change the math? And it turns out, yes. So that GPT model that takes $5 million to train, we can do it in about $400,000 today.
Now that you're doing this and you're getting this 10x improvement, what are the most interesting applications of your technology or your rewriting of the algorithms that you see or you're selling in the world today right now?
Yeah, so I think the biggest thing is enabling more industries to be able to use these methods, like large language models. And I'll tell you why that's important. Large language models are vastly different than kind of the ImageNet model. ImageNet was just applying a label to an input image, right? Large language models train on a very large corpus of data. To give you an idea of how large, GPT was trained on approximately 300 billion tokens. One token is approximately a third of a word. So 100 billion words is, 300 million books, something on that order.
Wow.
So it's a lot of information.
That's a lot of books.
It's a lot of books.
It's a lot of books.
So it's a lot of text, but what they can do is actually become a very flexible form of a database. They learn the input and put it into a form that is now human queryable.
So let's look forward a few years, or maybe 5 or 10 years even. You're doing already amazing things today, things that seem like magic tricks for today.
Right.
But I'm curious, when you look forward 5 to 10 years and you think about the other advances that you're going to drive with Mosaic ML, but maybe some of your colleagues here at Playground will drive in other areas of AI, what problems do you see us solving in 5 or 10 years? Or what are the cool new applications of AI that you think will be happening as you look forward?
Yeah, I think this comes down to, and I hate this hackneyed word, but I'm going to use it anyway, democratization of intelligence, right? Or knowledge or expertise, however you want to characterize it. But I always found it amazing that my dad had glaucoma, and there was one expert at Johns Hopkins who was the best guy to go to. It's just information. Why did you have to be routed to this one singular human, right? Because that person had knowledge in their head, and they could probably make the best recommendations and inferences because of that knowledge. What we can do now is actually start to bake these things into these neural networks and not only make it cheap to apply that knowledge, but also make it very consistent. For compliance purposes, this is great because sometimes you actually have subjectivity between different humans. The humans don't always agree with each other. And in this case, you can actually define those rules without subjectivity anymore because you have a machine that does it. You have to pick, this is the right way. Obviously sometimes it's going to come down to a judgment call. But I think this is what we're going to start to see is that across different fields, those expert calls that people have to make will tend to be automated and make things vastly cheaper. And access to things like healthcare should be way better, right? And this is what I see will be happening in the next 5 years.
The AI community, right? There's all this discussion about using these tools like AI, ML for good or for less good.
Yeah.
What do you think the obligation is of leaders like you inside the AI community to make sure the applications are for the betterment of society overall? Do you have a responsibility? Is it something that another group should be thinking about?
Yeah, it's a great question, and it is something I've thought a lot about. Actually, at Intel, we formed a responsibility framework for understanding how technology is responsible for sort of negative outcomes. Negative itself is a subjective term, right? And so this is what becomes complicated. It's sort of a moral argument many times. Any technology can be used for evil, right? And it's happened over and over again. I mean, you could take a microprocessor, and there's definitely code that's been written that runs on a microprocessor that has been used for bad stuff, right? Yep. So it comes down to now, how and when do you have responsibility as a technology provider? And sort of the essence of that framework is the closer your technology is to the application, the more responsibility you bear. So give you an example. If I'm making a technology, a camera that does face detection, and it's very easy to say this is a face I want to detect or not detect, and then that's used for, sort of racial profiling. You probably have some responsibility because you built a tool that enables face detection and differentiation. Like literally, that's what you did. The step to using it in a nefarious way is actually very short, very small. If you built if you're building chips, you're multiple steps away. And so yes, people can write code and build a system and then deploy it in this way, but your responsibility is way lower. And so you can't really say how someone's going to use something when you build something very low level. So that's the way I kind of think about it. I think policy needs to actually come into play at the higher levels of this stack. Yeah. This is something that as a society we need to think about, right? Because these technologies will have such a big lever arm on their influence in the world. Yeah. And we do need to regulate them. That absolutely has to happen, but I think the regulation has to stay at the top of the stack, not at the bottom. Because if you regulate at the bottom, you're going to squelch innovation. Yeah. Right. So this is kind of the way we thought about it. It's incomplete. There's a lot more to think through, but I do think regulation through voting mechanisms and sort of a democracy are important.
Great. Well, Naveen, thank you so much for your time today. It was a really wonderful, enjoyable conversation, but I think I and the audience learned a lot in this, and just best of luck for you with Mosaic ML.
Thank you.
I know that I'm going to be in touch about it, and perhaps some members of our audience should be in touch about how we use Mosaic ML inside of our own AI efforts going forward.
Awesome. Thanks for having me.